We're going to do some extra practice for solving rational equations. So this one says, solve this one. I know. First thing you want to do is try to see what values are not permissible into this equation. Okay, so those values are the ones that are going to give you 0 in the denominator. So first, in this fraction, y in the denominator, y cannot be equal to 0. Now we also do the same thing for y plus 5. So y plus 5 cannot be equal to 0. And we also do the same thing with y squared plus 5y cannot be equal to 0. Okay. Once you do that, you solve. So this one, we subtract 5. We have that y cannot be equal to negative 5. Here, though, notice that you have a quadratic. You can factor y, and you have y times y plus 5. If they can't be equal to 0, that means that separately they're not going to equal to 0. But we already have that. Y is not equal to 0, and y plus 5 is not equal to 0. So this one is redundant. Now, these are the values that are not allowed. Let's find a solution for the equation. Notice that when we factor here y squared plus 5y, we made this denominator. So I'm going to rewrite it, 3y plus 5 over y times y plus 5 plus y plus 4 over y plus 5 equals y plus 1 over y. Let me fix that 4. Looks pretty bad. Okay. Now, in order to add fractions, what do we always need? We always need a common denominator. But here, the denominators are not numbers. They're variables. And that's okay. The only thing you want to notice is that the least common factor between y plus 5, y plus 5, and y is y times y plus 5. So that means that I have to multiply this expression by y and this one by y plus 5. So you have 3y plus 5 over y times y plus 5 plus this one again. I'm going to multiply by y over y plus 4 over y plus 5. And this one I'm going to multiply by y plus 5 times y plus 1 over y. Once you do that, you do not have to multiply the denominators. You can leave it factored, but you do have to multiply the numerators. So you have 3y plus 5, y times y plus 5, plus, we distribute the y times y, so y times y, and y times 4. Y times y is y squared, y times 4 is 4y, equals, notice that this, here we have to FOIL, so y times y is y squared, y times 1 is plus y, 5 times y is 5y, and 5 times 1 is 5. And you leave it as y times y plus 5. Now, why am I not multiplying the denominator? Well, the reason is that when you put it in the same denominator here, so I'm going to write it as a sum with the same denominator. So you have y squared plus 4y plus 3y plus 5 over the same denominator. Notice that having the same denominator on both sides, once we cross multiply, the denominators are going to equal to 1. Okay? So if I multiply y times y plus 5 on both sides, right, then these denominators are going to cancel out. They're going to equal to 1. So by doing that, I don't have to even write it. We can jump that step and go straight to the numerators equal to each other. So y squared plus 4y, well, let's add those two together. 4y plus 3y is 7y, so I'm going to add those. Equals y squared plus 6y plus 5. Okay? Notice again that they're equal to each other. Okay? We then equal it to 0, so we move all of this to the left side of the equality. So you have y squared plus 7y plus 5 minus y squared minus 6y minus 5 equal to 0. Y squared minus y squared equals 0. 7y minus 6y is y. 5 minus 5 is 0, so you have y equals 0. But we initially said that y cannot be equal to 0. Therefore, this equation has no solution. And if you want to express that as a set, you just write the empty set. Now, for this problem over here, let's change the colors. This one's a little more tricky. The denominators look all different, but in reality, they're very similar. For this one, we will use the concept of difference of squares. A squared minus b squared equals a minus b, a plus b. Now, here we have x squared minus 1. 1 can be expressed as 1 squared because 1 times 1 is 1. Therefore, this becomes x minus 1 times x plus 1. Now here, you also can factor the 5. So you have 2 over 5 times x plus 1 minus 3 over x minus 1, x plus 1 equals 4 over x minus 1. And by doing that, you can see what the values that are not permissible. So first you have that x minus 1 cannot be equal to 0, and x plus 1 cannot be equal to 0. Hence, x cannot be equal to 1, or x cannot be equal to negative 1. Now we can proceed with the problem. So the question is, well, what's the least common factor between all of these? Well, notice that these two terms must be in there. There's one of them here, and there's one of them here. So we gotta write those extra ones. And there's also that 5 in here, so we also have to write that as well. So for the first term, I'm gonna multiply by x minus 1, top and bottom. For the second term, I'm just going to multiply by 5 over 5. The last term, I'm going to multiply by 5 over 5 and x plus 1 over x plus 1. Okay? Very similar to the previous example, we're not going to distribute the bottom. We're just going to distribute the top. So 2 times x is 2x. 2 times 1 is minus 2 over. I'm just going to write it neatly here. It's plus 1x minus 1. Minus 3 times 5 is 15 over 5x plus 1 x minus 1 equals 5 times 4 is 20, and 20 times x is 20x, 20 times 1 is 20. So you're left with 5 times x plus 1, x minus 1. Again, just similar to the previous example, we put them together. So you have 2x minus 2 minus 15 over 5 times x plus 1, x minus 1 equals 20x plus 20 over 5 times x plus 1, x minus 1. Again, the denominators equal to 1, so they cancel out. So you're left with 2x minus 17 equals 20x plus 20. We solve for x, so I'm going to subtract the 2x on the right and subtract the 20 on the left. Negative 17 minus 20, 20x minus 2x. Negative 17 minus 20 is negative 37. 20x minus 2 is 18x. So now we divide by 18. So x equals negative 37 over 18. And that will be your solution. Now for the last problem, here I decided to choose this one because it has a lot of complexity on it. Okay, first it has this quadratic equation here, then it has this cube equation. Okay, so get ready. Now the first thing I want to do is to factor. Now to factor x squared minus 2x plus 4, I can use the x method. A times c and b. So you have 4 for a times c and negative 2 for b. What two factors of positive 4 when you add them gives you negative 2? Well, let's see. 2, 4, 4 and 1, no. 2 and 2, no. Seems like there's none. Okay, so let's erase that one. That one does not factorize into a integer. So let's see x cubed plus 8. Well, this one is sums of cubes. Just like there's difference of squares, there's also sums of cubes. This becomes a plus b times a squared minus a times b plus b squared. In this case, you have x cubed plus 8, but a can be cubed if it were 2, so 2 cubed. So we're using this formula. This is x plus 2, x squared minus 2 times x plus 2 cubed, which is 4. Aha. So notice that this term is this term. So the only thing I need to multiply here will be x plus 2. So you have, oh, I forgot to mention, you have to exclude the values in the denominator. X plus 2 cannot be equal to 0. Therefore, x cannot be equal to negative 2. Now, this factors into a complex number, so we don't have to worry about this one. And this one factors into these two terms, which we already know x cannot be equal to negative 2. So now, we begin by multiplying on the left side by x plus 2 over x plus 2. On the first term on the right side, we need this entire expression. So x squared minus 2x plus 4, x squared minus 2x plus 4 times x over x plus 2. And on the right side, we leave it alone because x cubed plus 8 is this entire expression. So I'm going to just rewrite it as that so we don't get confused. And now we multiply. A times x is 8x. A times 2 is 16. X, so I'm going to distribute from the left side. X times x cubed is, x squared is x cubed. X times x is negative 2x squared. 4 times x is 4x. And then plus 24. Notice that I got rid of the denominator in one step, so I don't have to rewrite it again. From here, we equal it to 0, so I'm going to move these two guys to the right side. Now I'm going to have 0 equals x cubed minus 2x squared plus 28 minus 8x minus 16. Okay, and from here you have 0 equals x cubed minus 2x squared minus 8x. 16 plus 28, let's see, 28 minus 16 is 12. Positive 12. Okay, and then how do we factor here? Well, we factor the first three terms, the first two terms, and the last two terms. What can we factor between x cubed minus 2x squared? Well, we can factor in x squared, and you're left with x minus 2. And what can you factor between negative 8x plus 12? You can factor, no, you can't factor negative 8. Let me double check that all my calculations are correct, so we don't have to redo this. Let me see. Let's hit x. Okay. Let me double check. X plus 2 times 8. 8x plus 16. Oh, this is 4x. I saw the mistake. See? You always double check. And I knew there was a mistake because it wasn't factorizing, right? And we wanted to factor in order to find the solution. No biggie, we'll just fix it. Okay, so again, from here, 0 equals x cubed minus 2x squared plus 4x plus 24 minus 8x minus 16. Excellent. So 0 equals x cubed minus 2x squared. 4x minus 8x is minus 4x. 24 minus 16 is plus 12. All right. So 0 equals. Now we do the same strategy again. We factor. What can we factor here? We can factor x squared. You're left with x minus 2. 24 minus 16. Wait, what's 24 minus 16? 8. Again, it's gonna work. Sorry about that. Okay, plus 8. There you go. We factor the negative 4, and we're left with x minus 2. And we put them together, so you have x squared minus 4 times x minus 2. Okay? That means that x squared minus 4 equals 0, or x minus 2 equals 0. Well, that implies that x squared equals 4, or x equals 2. That implies that x equals plus or minus radical 4, and x equals 2. Well, what is the square root of 4? Is plus or minus 2. X equals 2. Now you see there's repeating values, but we have to be very careful because we already said that x cannot be equal to -2. Therefore, we got to exclude that from the domain. Therefore, your solution is just 2. Sorry about the little mistakes. You know, everybody makes mistakes, but we learn how to fix them and we get it correct. Thank you guys for watching. This will be the end for this video. If you have any comments, leave them below or ask me in class. Thank you.